After more than 20 years studying the biology of aging, one quiet pattern still surprises me. Many people begin noticing small changes in their vision long before they think of their eyes as aging. Perhaps it happens one evening while driving home. The headlights of oncoming cars seem brighter than they used to. Halos appear where clear light once was. Or maybe it happens in the morning, when the words on a phone screen look slightly softer, slightly harder to focus. At first, it feels like a minor inconvenience. A pair of reading glasses solves the problem. A brighter lamp helps with the crossword puzzle. Life moves on. But scientists have begun to suspect that something far more interesting is happening behind the scenes. What if these small visual changes are not simply about getting older, but about a microscopic structure in the eye slowly losing its chemical protection? Inside your eye sits a remarkable structure called the lens. Unlike most tissues in the body, the lens contains no blood vessels at all, no arteries, no veins, no direct nutrient supply. Instead, research suggests the lens survives using an internal antioxidant system, one built around molecules like glutathione, vitamin E, and protective enzymes that defend fragile proteins from oxidation. And those proteins are unusual. Many of them were created when you were a child and must last for the rest of your life. Imagine a crystal window designed to stay clear for 80 years. What happens when that window slowly loses its protective shield? And why are researchers beginning to look at something as small as seeds when exploring this mystery? Because the story of aging eyes may begin somewhere far more subtle than most people realize. And in the next part of this story, we need to talk about one of the strangest biological facts about the human eye. One of the most fascinating facts about the human eye is something most people never hear about. The lens, the clear structure that bends light so you can read, recognize faces, and watch the sunset, lives in a kind of biological isolation. Unlike your skin, your muscles, or even your brain, the lens has no direct blood supply. Pause for a moment and imagine that. Every other tissue in your body receives a steady stream of oxygen, nutrients, and antioxidants carried through blood vessels. But the lens must survive in a completely different way. Scientists often describe it as a self-sustaining crystal. It floats behind the iris, quietly relying on a delicate chemical environment maintained by the surrounding eye fluids. Inside this tiny structure lives a remarkable defense system built around antioxidants, especially a molecule called glutathione. Research suggests glutathione functions like a microscopic repair crew. It neutralizes oxidative stress before it can damage the proteins that keep the lens transparent. But here is where the story becomes intriguing. As people age, studies indicate the levels of glutathione inside the lens gradually decline. Without that protection, oxidative molecules begin interacting with lens proteins. Think of it like a perfectly clear window exposed to years of sunlight and dust. At first, the changes are invisible, but slowly the clarity begins to soften. Why does this matter? Because the proteins inside the lens are not like most proteins in the body. They are not regularly replaced. In fact, many of them were created decades ago. And that brings us to a biological mystery that researchers still find astonishing. How do proteins built in childhood continue functioning clearly for 70 or even 80 years? and what happens when their protection slowly fades. That is where our story becomes even more fascinating. Here is a detail about the human eye that many scientists still describe with a sense of wonder. Most tissues in the body are constantly renewing themselves. Skin cells replace themselves every few weeks. Blood cells circulate and regenerate. Even the lining of your gut renews rapidly. But the lens of the eye plays by very different rules. Inside the lens are specialized proteins called crystallins. These proteins are arranged in a precise structure that allows light to pass through without scattering. In many cases, these crystalline proteins were formed before you were even born. And unlike most proteins in the body, they are rarely replaced. Researchers sometimes call them one-time proteins. Imagine building a glass window once and expecting it to remain perfectly clear for the rest of your life. For decades, for 70 or 80 years. That is essentially what your eye lens is attempting to do every single day. But over time, small molecular changes begin to accumulate. Oxidative stress, ultraviolet light, and normal metabolic activity slowly affect these delicate structures. Studies suggest that when the protective antioxidant systems weaken, especially molecules like glutathione, the crystalline proteins can begin to fold or clump together. When that happens, light that once passed smoothly through the lens begins to scatter. Sometimes the first signs are subtle. A page of text looks slightly dimmer. Streetlights develop faint halos. Colors lose a little of their brightness. Have you ever noticed how older photographs sometimes develop a cloudy haze over time? Scientists often use that image as a metaphor for what can happen inside the lens. But this raises a fascinating question. If these proteins cannot easily be replaced, how does the body protect them for so many decades? And this is where nutrition researchers began looking in a surprising direction. Not toward exotic medicines, but towards something as simple as tiny seeds. For many years, researchers believed that vision changes with age were simply unavoidable, a natural consequence of time passing, a biological clock slowly ticking forward. But over the past 2 decades, something interesting has happened in the field of nutritional science. Scientists began looking more closely at how nutrients interact with the eye's antioxidant systems, especially the delicate chemistry protecting the lens and retina. And what they discovered was quietly fascinating. Certain nutrients appear to act like molecular bodyguards, helping defend cells from oxidative stress. Compounds such as vitamin E, zinc, lutein, zeaxanthin, and omega-3 fatty acids have all been studied for their relationship to eye health. Research suggests these nutrients may support the systems that keep the eye functioning smoothly as the decades pass. But there was another discovery that surprised many scientists. Some of the most concentrated sources of these compounds were not found in rare plants or complicated supplements. They were hiding in something remarkably simple: seeds. Tiny biological packages designed by nature to contain everything needed to grow an entire new plant. Inside them are dense stores of minerals, antioxidants, and protective fats. Think of a seed as a miniature survival capsule. Every nutrient inside it exists to protect fragile biological structures from damage. Does that sound familiar? Because inside the human eye, delicate structures, like the proteins in the lens, face a very similar challenge, which raises an intriguing possibility. Could some of these tiny nutrient packages support the antioxidant systems that protect our eyes?
Researchers have begun exploring that question for years, and when scientists started ranking seeds by the compounds they contain, a fascinating hierarchy began to emerge. But the sixth seed on that list holds an unexpected secret most people never realize.
Let us begin with a seed many people recognize but rarely think about in connection with their eyes: sesame seeds. These small, ivory-colored seeds have been used in traditional foods for thousands of years, yet modern nutritional analysis has revealed something interesting about their composition. Sesame seeds are rich in zinc, copper, and vitamin E, minerals and antioxidants that researchers frequently study in relation to retinal health and cellular protection. Zinc, for example, plays a role in transporting vitamin A within the body. Studies have suggested this mineral may support the biochemical pathways involved in visual processing. Copper participates in antioxidant enzyme systems, and vitamin E, as scientists often describe it, acts like a lipid shield, protecting delicate cell membranes from oxidative damage. But here is the small detail most people overlook. Sesame seeds contain a natural compound called phytic acid. Phytic acid is not harmful. In fact, it plays an important role in plant biology, but it can bind to minerals like zinc and copper, making them harder for the body to absorb. So the nutrients are technically there, but they may remain partially locked away. Interestingly, food scientists have long observed that gentle roasting can reduce phytic acid levels, making these minerals more available. It's a little like opening a locked door inside the seed. Imagine a tiny vault filled with minerals, waiting for the key. This is why traditional cuisines often toast sesame seeds briefly before using them. But sesame seeds are only the beginning, because the next seed on the list contains two pigments that scientists sometimes describe as natural sunglasses for the eye, and their story becomes even more fascinating. The fifth seed in this quiet ranking looks humble on the outside. A small green kernel, often sprinkled on salads or eaten as a snack. Pumpkin seeds. Yet inside these seeds, researchers have identified compounds that play a particularly interesting role in vision science. Two pigments called lutein and zeaxanthin. If you could look directly into the center of the human retina, you would see a small region known as the macula. This structure is responsible for sharp central vision, the ability to read, recognize faces, and focus on fine details. And here is something remarkable. The macula naturally contains a yellow pigment made largely from lutein and zeaxanthin. Scientists often describe these molecules as internal light filters. Research suggests they help absorb high-energy blue light and reduce oxidative stress within retinal tissues. Think of them as microscopic sunglasses built directly into the eye. Over time, however, the density of these pigments can vary depending on nutrition and metabolism. That is one reason researchers have shown interest in foods containing these carotenoids. Pumpkin seeds happen to contain small but meaningful amounts of these compounds, along with supportive minerals. But like sesame seeds, pumpkin seeds also contain phytic acid, the same natural mineral-binding compound. Interestingly, traditional preparation methods often include soaking seeds, which studies suggest may reduce this barrier and improve mineral availability. Again, we see the same pattern. Nature places valuable nutrients inside the seed, and preparation unlocks them. But the next seed on our list shifts the story in a new direction, because sometimes the eye is not simply lacking nutrients. Sometimes it is quietly dealing with inflammation. If the eye were a landscape, the retina would be its most delicate ecosystem. a thin, intricate layer of neural tissue where light becomes electrical signals, and those signals become the images we recognize every day. And like many living systems in the body, the retina is sensitive to inflammation. Researchers often describe inflammation not as a single event, but as a spectrum. In some cases, it is acute and obvious. In others, it exists at a much lower level, quiet, persistent, and difficult to notice. Some scientists call this chronic low-grade inflammation. Studies have suggested that certain fatty acids may influence these processes within tissues throughout the body, including the eyes. And this is where hemp seeds enter the conversation. Hemp seeds contain a notable balance of omega-6 and omega-3 fatty acids, often close to a 3-to-1 ratio. Researchers studying lipid biology have explored how these fats may support the body's inflammatory signaling pathways and cell membrane health. Why might that matter for the eye? Because the retina and the tear film that protects the surface of the eye both rely on healthy lipid layers. When these layers function well, the eye's surface remains stable and comfortable. Imagine a calm lake reflecting the sky clearly. But when the surface becomes disturbed, the reflection becomes distorted. Some scientists use this metaphor to explain how delicate the eye's environment can be. Healthy fats may play a role in maintaining that balance. But hemp seeds are only part of the story, because the next seed contains a fat that researchers often describe as one of the structural building blocks of the retina itself. And that connection leads us somewhere very interesting. Every time light enters your eye, a remarkable transformation occurs. Photoreceptor cells inside the retina capture that light and convert it into electrical signals the brain can interpret. These cells are among the most specialized in the entire body, and they rely on a very specific structural fat called DHA, docosahexaenoic acid. DHA is a long-chain omega-3 fatty acid found in high concentrations in retinal cell membranes. Scientists often note that it helps maintain the flexibility and signaling ability of these cells. Without adequate structural lipids, cell membranes can lose some of their responsiveness, like wires that slowly lose conductivity. So where does DHA come from? The body can produce small amounts from a plant-based omega-3 fat known as alpha-linolenic acid, or ALA. And this is where chia seeds enter the story. Chia seeds are one of the richest plant sources of ALA. Nutritional studies often highlight their dense omega-3 content along with fiber, minerals, and antioxidants. But there is a curious observation researchers frequently mention. Whole chia seeds can sometimes pass through the digestive system largely intact. The outer shell is quite resilient. Food scientists have therefore observed that grinding seeds may increase the availability of their internal nutrients. Imagine a tiny capsule being gently opened. Once exposed, the oils and nutrients inside become easier for digestion to access. But omega-3 fats are delicate molecules. They can oxidize when exposed to air and light, which means freshness suddenly becomes important. And the next seed on our list contains an even more concentrated version of this same omega-3 family. Among plant foods studied for omega-3 content, one seed consistently appears near the top of the list: flax seeds. Nutritional researchers often describe flax as one of the richest plant sources of alpha-linolenic acid, the same omega-3 family connected to structural fats in the body. Inside these small golden or brown seeds lies a dense concentration of beneficial lipids, lignans, and fiber. But flax has something in common with chia seeds. Its outer shell is extremely tough. If you have ever seen whole flax seeds sprinkled on bread or cereal, you may notice they pass through digestion almost unchanged. Scientists studying nutrient absorption have therefore pointed out that grinding flax seeds dramatically increases the availability of their internal oils. In other words, the nutrients become accessible once the shell is broken. Picture a vault opening. Inside are delicate oils that must be protected from oxidation, exposure to air, light, and heat. That is why nutrition researchers often emphasize freshness when discussing seed oils. Once ground, those fats begin interacting with the environment. But here's something intriguing. Fat-soluble nutrients, those carried in oils, often rely on other dietary fats to be absorbed efficiently. Think of it like passengers needing the right vehicle to travel through the digestive system. Certain monounsaturated fats can act like that vehicle. And this brings us to the final seed in our story, a seed that scientists often associate with one of the most important antioxidant defenders in the human body. If there is one nutrient scientists consistently study in relation to cellular protection, it is vitamin E. Vitamin E belongs to a family of compounds known as tocopherols, and one form, alpha tocopherol, is especially active in human tissues. Researchers often describe vitamin E as a membrane guardian. Cell membranes are made largely of lipids, and lipids are vulnerable to oxidation. Vitamin E sits inside these membranes, intercepting oxidative molecules before they can damage the structure. It is a bit like a firefighter stationed inside the walls of a building, always present, always ready. And one of the richest natural sources of alpha tocopherol happens to be sunflower seeds. These small seeds contain remarkable concentrations of vitamin E along with selenium, magnesium, and supportive fats. Some studies exploring antioxidant networks have suggested that vitamin C can interact with vitamin E, helping restore its antioxidant capacity after it neutralizes oxidative molecules. Scientists sometimes describe this as a kind of recycling process within the body's antioxidant system. Picture a shield that repairs itself after each impact. Of course, the body's chemistry is far more complex than a simple metaphor, but this idea illustrates how nutrients rarely work alone. They often function as part of interconnected systems, which raises an interesting thought. What happens when multiple supportive nutrients, antioxidants, minerals, and healthy fats appear together in a consistent daily pattern? That question leads us to the final chapter of our story, and it has less to do with a single seed and far more to do with consistency over time.
When people think about improving health, they often look for dramatic changes, a powerful supplement, a sudden transformation, a result that appears overnight. But biological systems rarely behave that way, especially the eye. The proteins inside the lens were built decades ago. The retinal cells responsible for vision operate with extraordinary precision, and the antioxidant systems that protect them function slowly and continuously. Researchers studying nutrition often emphasize a simple principle: consistency matters more than intensity. Imagine placing a drop of water on a stone. One drop changes nothing, but the same drop falling every day for years can slowly reshape the surface. Human biology works in a surprisingly similar way. Small, repeated signals, nutrients, sleep patterns, light exposure, movement, gradually influence cellular systems. The eye is constantly responding to these signals. Scientists continue exploring how antioxidants, essential fats, minerals, and plant compounds interact with the body's protective pathways. Some studies suggest improvements in comfort or dryness can appear relatively quickly, while structural biological changes may unfold more gradually. Weeks, months, sometimes longer. And perhaps that idea offers a hopeful perspective on aging, because aging is not a sudden event. It is a long conversation between the body and the environment. Every morning meal, every hour of sleep, every moment of sunlight adds another sentence to that conversation. So here is a question worth reflecting on. If tiny choices repeated over time can influence the body's chemistry, what other quiet systems inside the body might still be listening? And how many of them are waiting for the right signals to respond?